Hello everyone and welcome back. So in this video I want to do a quick walkthrough of the curriculum and talk about what to expect from this course. This course explains the concepts from basic to advanced, so it's advisable not to miss any section before you go to the next section. The very first section is introductory section, in which I explain basic content such as what is data structure, what is algorithm, and why we need them. Then the next section is called recursion, which is really important stuff. So this is used in many algorithms. So it's very important to learn it before diving into the deep data structures and algorithms, because it comes up late on in many of our algorithms. And there are lots of interview questions about recursion, and main ones are explained in cracking recursion interview question sections, which is our next section. Then the next topic is big O notation. It is the way of describing or talking about the performance of efficiency of code. So we use this section all the time, so definitely do not skip that. And there are many interview questions that are related to big O. So the most asked questions are explained here in the section of cracking big O interview questions. Then we move on to the next section called arrays, in which we explain different types of arrays such as one-dimensional array, two-dimensional arrays, and we have introduced how they are represented in memory, and we have calculated time and space complexities for array operations. The next, we shift over to talk about Python list, which is very similar to the arrays, just a small difference, so we explain the differences between them. Then we analyze the interview questions related to arrays and Python list. Then from here, we continue to explain built-in data structures of Python, which are dictionaries and tuples. And we have analyzed these data structures by using big O notation to calculate the performance. Then we continue to the longest section of this course, which is called linked list. Here we have covered all details of linked list with performing all operations on different types of linked list, such as single linked list, circular single linked list, double linked list, and circular double linked list. You will never find such detailed information on any other course on the internet about linked list. Additionally, we have explained famous interview questions about linked list in a separate section. Then we move on to the two more additional data structures, which are stacks and queues, and these are very commonly used data structures, and here also common interview questions are explained about them. Then from here we start another very detailed section which describes whole tree data structures, in which we include binary tree and the main concepts of binary tree, such as pre-order traversal, in-order traversal, post-order traversal, and level order traversal. So here again we recall things like big O notation and recursion. Then from here we continue to do binary search tree and then AVL tree. In AVL tree we have covered important concepts like left-left condition, left-right condition, right-right condition, and right-left condition. And we have implemented these conditions in inserting or deleting a node in AVL trees. This is a fun section in my opinion, because there are a lot of challenging problems that we are doing over here. Then we are going to the binary heap, which is related to trees, but a very special case of tree. And we talk about common operations of binary heap. And finally, we go to the last type of tree, which is trie. The trie takes characters as a node, so it's very useful especially when developing applications like dictionaries. Then from here, we go to the hashing section. So here we talk about a very particular data structure, which is very interesting. So here we explain how Python built-in data structures work and how they are implemented behind the scenes, and how will you implement a key value pair data structure by yourself. So from here, we get to the sort of second part of the course. Up until this point, we have been talking about different types of data structures. But from this section, we will start to talk about different types of algorithm. So from this slide to the end of course, we will talk about different types of algorithms, which are very essential concept of computer science. So we move on to the sorting algorithms, in which we will learn several different sorting algorithms. We start with bubble sort, which is often considered the easiest one. And we move on to the selection sort, and then we move to the insertion sort. And those three form a little group of intermediate or elementary sorting algorithms. Then we move to the bucket sort, then merge sort, and then quick sort. And these sorting algorithms all involve recursion and big O notation. That's why it's very important not to skip those lectures before you come over here. Then we finish up this section with heap sort. Then from here, we go to another detailed section which is called graph algorithms, something that a lot of people are intimidated by. So here, first we start to explain graph data structures and show how to implement them using Python. Then we continue to implement graph algorithms like breadth first search, depth first search, which are used in graph traversal. Then we continue to find topological sort for a given graph. Then from here, we will continue to solve problems like single source shorts path problem and all pair shorts path problem. So we will solve these problems using 4 different algorithms such as breadth first search, Dijkstra's algorithm, Bellman-Ford algorithm, and Floyd-Warshall algorithm. And we will also talk about why we cannot use depth first search algorithm for these problems over here. Then from here, we will continue to the minimum spanning tree, which is special type of graph. And we will solve this problem using 2 different algorithms like Prim's algorithm and Kruskal algorithms. Then with this, we conclude the graph section and we move on to the next section, which is called greedy algorithms. So here we talk about which algorithms use greedy approach, and we solve problems like activity selection problem, coin change problem, and fractional knapsack problem using greedy approach. Then the next section is divide and conquer algorithms. Here I will talk about main properties of divide and conquer algorithms, and we will learn how can we identify and solve problems using divide and conquer approach. Then we will solve problems like number factor problem, house robber problem, convert one string to another string, zero knapsack problem, longest common subsequence problem, longest palindromic subsequence or substring problem, minimum cost path problem using divide and conquer approach. And we will create methods in Python for those problems over here. And from here we will continue another detailed section which is called dynamic programming. I know many people are curious about learning dynamic programming. So here I will talk about main properties of dynamic programming such as optimal substructure property and overlapping subproblems property. Then we will learn 2 methods of dynamic programming which are top-down with memoization and bottom-up with tabulation. And I'll show you 4 steps to convert divide and conquer algorithm to dynamic algorithm. Then we will continue to learn common problems that can be solved using dynamic programming such as number factor problem, house robber problem, convert one string to another string problem, zero knapsack problem using dynamic programming. So after this section, I have created a challenging dynamic programming exercises section for those who like pain and misery, because these are quite hard problems. So if you are interested to solve hard problems in dynamic programming, you can continue with this section over here. Then finally, we will reach the Wild West section, which includes coding exercises for all topics that we have explained in this course. So that is where we finish this course. But this is not the end, because I'm in process of recording new sections based on your requirements. And more sections are about to come. So hopefully you will enjoy the course. So see you in the course.
Hi there. Before we get started digging into different types of data structures and algorithms, I want to talk about what are data structures and why do we need them. One sentence description of data structure would be that they are basically different ways of storing data on our computer. This sentence might not be clear right now, so let's give you a concrete example here. Let's say we have a bunch of woods here, and it can be easily seen that they are not organized. So if we want to choose a black color wood, we face a problem here. We need to check all of them one by one and to find out the black one. Since these items are not in an organized way, selecting black one is time consuming and difficult. Okay, let's look at the organized way of these items. What have we done here? We have just taken the unorganized items and put them in an organized way. So selecting a black wood from this list is very easy, and it takes less time to find it. We know that it's obviously seen that it's here. So when it comes to data structures, we are doing same thing that we have done here, organizing the items. It's very clear that all softwares are dealing with data. So they do some operations based on given data. Before processing the data, we have to organize data in a certain way that makes the process very efficient. From software application performance point of view, the efficiency and the performance of software depends on how the data is stored, organized, and grouped together during program execution. Every day during our daily lives, we can see various types of data structures. There might be a crowd of people who want to get a ticket from the concert, but without organized way, it becomes almost impossible to get ticket. The organized way of people to get ticket is queue. It's also called queue data structure in computer science, which is first in and first out. As you see from the picture, a person who comes first buys tickets first. So this is called first in, first out in computer science. Another example is, imagine there's a bunch of books on the table and you want to return them to the library. It's obvious that without organized way of ordering, we cannot carry these books. On the other hand, if we order them in this way, it becomes easier to carry them. And this reminds us stack data structures in computer science. Okay, we understand that we use data structures to make our application very efficient. The problem is that there are many different types of data structures. So which one should we choose for best performance of software or app? You will find an answer to this question throughout this course, while explaining all data structures and their use cases. And this is the main reason why big companies like Google, Apple, Amazon, or Facebook ask questions about data structures and algorithms from the candidates during their interview process. A professional software developer has to know which data structure to choose for a particular app, which has a direct effect on the performance. So that's all for this video. In the next video, we will examine what's an algorithm. Now in the last lesson, we got an overview of what data structures are and why they are important to us. So in this lesson, I want to take you one step further and look at algorithms. What's an algorithm? One definition might be a set of steps to accomplish a task. Let's look at the previous example that we gave for data structures in which we organize wooden items. So if we want to use these organized wooden items for flooring, we need to accomplish several steps. First step is choosing flooring, which color that we are going to use. Then we need to purchase it and bring it to home. And next step is prepare subflooring. And the next thing that you need to do, you need to determine the layout of flooring in the space. Finally, we trim the door casing and our floor is ready. So as you see, we have completed a set of steps to accomplish our task of flooring. So here our data is wooden items. First, we structured them. Then we completed the steps, which is a set of rules as mentioned in the definition of algorithm. Now you have a clear understanding of what's an algorithm. Every day during our daily lives, we use algorithms to execute our duties. You might have an algorithm for getting from home to work. First you need to go to bus stop, then take bus, then go to the office. Or for buying a coffee from Starbucks, you need to go to Starbucks and pay for the coffee and get the coffee. The tasks that we perform during the day are all algorithms. So here I want you to pause the video and comment below what algorithms are you performing during the day. Okay, hopefully you pause the video and comment below about your algorithms. In computer science, an algorithm is a set of rules for a computer program to accomplish a task. Learning about different types of algorithms and knowing when to apply them allows us to write time and memory efficient programs. Let's look at few famous algorithms that are used by big companies. You might be interested how do Google and Facebook transmit live video across the internet. The answer is they are using audio and video compression algorithms to transmit live videos. Or you might be interested which algorithm is used to find the shortest path on the map. These are graph algorithms that are used in Google, Apple, and Microsoft's maps to find shortest path between two locations. Algorithms are used in space exploration as well. Optimization and scheduling algorithms are used by NASA to arrange solar panels on the International Space Station. So by getting deep knowledge about existing algorithms and applying the right one can make our programs faster. It's also important to know how to design the algorithms as well as how to analyze their correctness and efficiency. There are two criteria to make good algorithms. The first one is algorithm solve the problem correctly, and the second one is it does it so efficiently. So all in all, in this video we have learned what an algorithm is and how different types of them are used by famous companies. In the next video, we will look at why data structures and algorithms are important and why famous companies ask questions related to data structure and algorithms during interview from the candidates. Now that we have understood the concept of data structures and algorithms, it's time to see why they are so important and why companies ask questions related to them at the interviews. Let's answer the first question, why data structures and algorithms are important. As a software developer or a computer scientist, our responsibility is to perform operations on data. We basically perform the following steps. Take data as an input, process it, and give back processed data an output. The input can be in any format. For example, if you look at the Google Maps, you provide starting and ending destination points as an input to Google Maps. It processes this data to find the shortest path between this location and provide us as an output. To make this process efficient, we need to optimize all these three steps. It's very obvious that the most we can optimize is second step, where we can have data structures and algorithms. So by using graph data structures and Dijkstra's short path algorithm, Google Maps is able to find the shortest path between provided points very efficiently. Let's look at another example. By now we know that data structures refers to the way we organize information on our computer, and this has a great impact on performance. Okay, suppose you want to have a book on algorithms from library. To get it, first you have to go to computer science section, then the algorithm section. As you see, it's very easy to find the book that we need in this way. On the other hand, if these books are not organized in this manner and just distributed randomly, it will be almost impossible to find the book that we need. This is the way a librarian organizes books in a particular form to efficiently perform a task. Here, books are the data, arranging them is a data structure, and find book that we need is algorithm. Thus, you can easily see how important data structures and algorithms are. In this manner, software developers process and look for the best way to organize the data, so it can be processed based on input provided. Okay, now we have answered the question of why they are so important, and I hope you understand the concept. Let's continue to answer the question, why do most companies ask questions during interviews related to data structures and algorithms? It's very clear that solutions to many problems that are related to software development can be found on the internet. By copy-pasting someone's code without understanding the logic behind it, it's not possible to become a professional software developer. By asking questions related to data structures and algorithms, the interviewer checks the problem-solving ability of a candidate. For instance, even though today's computers come with more memory, if the developer does not handle memory management technique, the program may leak and lose the memory. This means that without understanding data structures, the code may end up with a memory leak. The second reason for this is that interviewer has limited time to evaluate a candidate. So by asking such questions, an interviewer can evaluate fundamental concepts of programming, This means that if a candidate is a good at data structures and algorithms, she or he can learn any new technology or programming language easily. You just need to learn the syntax of new programming language. And that's it for this video. Hopefully you understand why data structures are important in programming. So in the next video, we will concentrate on types of data structures. Alright guys, so now we have learned that what is data structures and how it is important for a software developer. Now in this video, let's see what different types of data structures that we have. The data structures can be broadly grouped into two basic types, and that includes primitive data structures and non-primitive data structures. These groups are on the base of either predefined in the programming language or defined by a user. The data structures that are built in the programming language itself, which are available to the programmer, are referred as a primitive data structures. The most common primitive data structures are integer, float, character, string, or boolean. They are included in almost all programming languages. I have included definitions of these data structures in the resource section of this lecture. Another type of data structures is non-primitive data structures. They are also referred as user-defined data structures. Non-primitive data structures are derived from primitive data types by combining two or more primitive data structures. These data structures can be subdivided as linear data structures and as nonlinear data structures. So what's a linear data structures? In the linear data structures, the data items are arranged in memory in a linear sequential manner, and they can be either static or dynamic. In static linear data structures, associated memory locations are fixed at compile time. But in the dynamic structures, associated memory locations change. Here I'm not going to provide detailed information about these data structures in this lecture because we will discuss them very detailed in upcoming lectures. However, when it comes to nonlinear data structures, the data item is connected to several other items. They are not organized sequentially. Here it's possible for a data item to be connected with more than one data items. Graph and tree data structures are nonlinear data structures. As you see, we have various types of data structures, and you might be wondering why do we need so many different types of data structures? So the answer is each of these data structures has its own unique properties which work very efficiently in different circumstances. For example, graph data structures work perfectly for maps, and stack data structure works perfectly when you have backward and forward buttons in your application, due to its first in last out nature. So hopefully you have understood different types of data structures that we have. And in the next lecture, we will look at different types of algorithms. Now in the last lecture, we have learned different types of data structures. In this lecture, we will look at types of algorithms. Now in these lectures, there might be some terms that you may not understand, and you might have difficulties with understanding the concept. Don't worry about that, because everything that I mentioned here will be discussed in detail in upcoming lectures. Algorithms can be classified based on the problem they are trying to solve, such as sorting algorithms, searching algorithms, and so on. Or they can be classified based on the problem-solving approach. Please note that here we are just classifying together the algorithms that use a similar problem-solving approach. The purpose here is to highlight the various ways in which a problem can be attacked. Based on this criteria, algorithm types can be simple recursive algorithms, divide and conquer algorithms, dynamic programming algorithms, grid algorithms, brute force algorithms, and randomized algorithms. Okay, let's see what these algorithms are about. The first type is simply recursive algorithms. Such algorithms work in the same way as iterative algorithms. The recursion acts as a loop. If you hear a recursion term for the first time, you can think of this an algorithm that calls itself recursively. I will explain it in detail in the recursive section. The sample algorithm for recursive algorithm can be like this. Here, as an input, we have an array A of n numbers, and the output is the sum of numbers in the array. Here, the algorithm first checks the number of elements. If the number of elements is 1, then it returns the first element. Otherwise, it recurses all elements except the last one and adds the last one at the end. This sample shows how recursive algorithm works. Here you see that inside some function, we are calling the sum function itself with different parameters. This is how recursion works. The next type of algorithm is divide and conquer algorithms. This type of algorithm consists of two parts. First part is they divide the problem into smaller subproblems of same type and solve these subproblems recursively. And the second part is we combine the solutions to the subproblems into a solution to the original problem. Traditionally, an algorithm is called divide and conquer if it contains at least two recursive calls. Quicksort and merge sort algorithms can be examples for divide and conquer algorithms. Okay, here, let me continue with the dynamic programming algorithms. They work based on memoization, which means that these algorithms remember the past result and use them to find new result. These type of algorithms are generally used for optimization problems. The goal is to find the best solution among multiple solutions. Here again, I don't want to go in details because, as I mentioned before, these algorithms will be discussed in detail in upcoming sections. Okay, we'll continue with the next type of algorithm. The next type of algorithm is grid algorithms. These algorithms are also for finding the best solution. They work well for optimization problems. A grid algorithm works in phases. At each phase, we take the best we can without worrying about future consequences, and we hope that by choosing a local optimum solution at each step, we will end up at a global optimum solution. And the next type is brute force algorithm. It simply tries all possibilities until satisfactory solution is found. For instance, finding the best path between two locations. And the last type is randomized algorithms. These algorithms use a random number at least once during the computation to make a decision. You will see in the upcoming sections that the quicksort algorithm works based on random number to choose a pivot number and make a decision based on this. And with this, we have finished the last type of algorithm. Okay, that's all for this lecture, and hopefully you have an idea now on different types of algorithms. And this is the last video for this introductory section. From the next lecture, we will start with a new section in which we will learn everything about big O notation. See you there.